Hi everybody, and once again welcome to Pankaj Sir's Echelon tutorials. In today's session rather, we are going to deal with the chemistry subject only. And as you know, we were doing that stoichiometry, the chapter stoichiometry. I think we have done some 2 videos on that. Perhaps this must be the third video or the fourth video. Let us see. Now, this is the continuation of that stoichiometry, and let us start with this example number 2 over here. Now, this is that calculate the mass of KOH, that is potassium hydroxide, that needs to be used to prepare 500 centimeter cube of a 2 mole per decimeter cube solution in water. And AR is given for hydrogen 1, oxygen 16, and for potassium 39. Okay. So let us see how to solve this problem. Calculate the mass of KOH. So they have asked you to find out the mass of KOH. Okay, so first we'll try to find out what is the mole of KOH. Okay, so let us use this formula for mole, that is N is equal to concentration into volume in liters. Okay, now liters and decimeter cube is one and the same. I have told you this earlier also. Decimeter cube and liter means one and the same. Fine. Okay. So N is equal to C into V, that is the volume in liters, and C is the concentration, and concentration will be in mole per decimeter cube. Okay. Fine. So the volume is given for QH as 500 centimeter cube, but since the volume has to be in liter, you have to divide this 500 by 1000, and that makes 0.5 liter or decimeter cube. Fine. Then the concentration of this particular KOH is already given as 2 mole per decimeter cube. So that you have to take as it is. So now substituting the values, you get N is equal to 2, that is concentration, multiplied by 0.5, which is the volume. And 2 multiplied by 0.5 works out to 1 mole. So the mole is equal to 1, okay, for this QOH. Fine. Now let us try to find out the mass of this QH. Mass will be equal to this formula we can use. N is equal to mass in gram upon the AR, okay, or rather MR, because it is KOH, it's a compound. Okay, so we'll take MR. So since the number of moles is 1, so for N I'll take 1 equal to M upon MR for KOH is nothing but 56. That you can get from here, 39 K plus O plus H. So 39 plus 17 works out to 56. So 1 into 56 will give you the mass of KOH. So 56 gram is the mass of KOH that is required. Okay. So this particular question has been solved. Now next is for the following examples. Okay. Now these are the examples. For these examples, you have to follow this AR values, that is hydrogen 1, carbon 12, etc. is given over here. Now these are lot many questions, okay, some 11 to 12 questions, okay, and after doing these questions, you know, you will become very firm in your stoichiometry, the basics. Okay, fine. So calculate the number of moles in 2 gram neon atom, 2 gram neon atom. So we are going to use this formula, N is equal to M upon AR. Okay, N will be equal to, mass is given as 2 grams, so M I'll take as 2, and AR is for neon. AR you can see here for neon, yeah, it's over here. Neon AR is given as 20, so 2 upon 20, that's that works out to 0.1 mole. So the answer for A part is 0.1 mole, right? Then for the B part, uh, 4 gram of magnesium atom. So what you will do is N is equal to M upon AR again. So M will take as 4 and AR will take as 24, because magnesium AR value is 24. That works out to 1 by 6, and that works out to 0.167 mole. Okay. C part, 24 gram of carbon atoms. So the N will be equal to 24 upon 12, right? So that works out to 2 mole. That was question number 1, ABC. Let us do question number 2. Calculate the number of atoms in 1 mole of calcium. Okay, in 1 mole of calcium. So in 1 mole of in 1 mole of calcium, yeah. So here 1 mole of any atom or any element will contain 6.02 into 10 raised to 23 atoms. So this is the answer for A. B is carbon dioxide. 1 mole of carbon dioxide will contain how much? So carbon dioxide is a molecule. So you'll have to take the AR of the constituent atoms and you'll have to add up. So AR of carbon is 12. Okay. AR of oxygen is uh, 16, and you have 2 oxygen, so it will be 2 into 16. Okay, so your answer will be 1 mole of carbon dioxide has okay, they have asked you calculate the number of atoms in 1 mole. Okay, just atom they have asked you. So in 1 mole, the number of atoms here will be not 2 plus 1, 3. It will be 2 into, see, it has 2 atoms of oxygen and 1 atom of carbon. That way it has 3 atoms. But the number of atoms in 2 moles of oxygen will be 2 into 6.02 into 10 raised to 23. And in 1 mole of carbon, you will have again 6.02 into 10 raised to 23. And when you add up these two values, you will get 2 times 6.02 plus 1 times 6.02. That is 3 times 6.02 multiplied by 10 raised to 23. And 3 times 6.02 will work out to 1.8 something. Okay, 806. So 1.8 into 10 raised to 24. This should be the answer. 1.8 into 10 raised to 24. So this many atoms you will find in 1 molecule of carbon dioxide, right? C part of the question is methane. Now 1 methane, 1 CH4 contains 1 carbon atom and 4 oxygen atom, right? 1 carbon atom and 4 oxygen atom. The meaning of this is 1 mole of carbon atom will contain how much? 6.02 into 10 raised to 23 atoms of carbon, right? And 4 mole of oxygen will contain 4 into 6.02 into 10 raised to 23, isn't it? So when you work out this, you will get 5 into 6.02 into 10 raised to 23 atoms, which works out to 30.1 into 10 raised to 23 atoms. And this in the standard form you can write as 3 into 10 raised to 24 atoms. Okay, so this is how you have to calculate the number of atoms, okay, in a given compound or an element, right? Next question is question number 3. Calculate the mass of 0.1 mole of oxygen molecule. Now you'll have to use this formula. N is equal to M upon Mr. Okay, so N is the number of moles which is given as 0.1. So 0.1 is equal to M upon. Now oxygen is a molecule, diatomic molecule. So the Mr value of oxygen will be 16 plus 16, 32. So M upon 32 you will get. Okay, so M will be equal to 0.1 times 32, which works out to 3.2, and you'll have to add that gram because it's mass. Now this one, 5 moles of, okay, 5 moles of sulfur atom. So 5 will be equal to M upon, now sulfur ka AR value is 32. So 5 into 32 will be the answer for M, that is 160 gram. Okay. Then again this 0.25 mole of sodium atom contains, now what is the mass of this 0.25 mole of sodium atom? So N you will take as 0.25, M you will keep it as it is, upon 23 is the AR value of sodium. So 23 into 0.25 works out to 5.75 gram. This is the mass of 25.25 mole of sodium atom. Next question is calculate the number of moles in 9.8 gram of sulfuric acid. Now here in all these questions the mass is given to you and you have to convert it into the moles. So N is equal to M upon Mr, and N will be equal to, mass is given as 9.8 upon Mr of H2SO4 will be 98. Okay, so 9.8 upon 98 works out to 0.1 mole. So the answer for A is 0.1 mole, right? And H2SO4, the Mr will be 98. So H2 means 2 plus S is 32 and O4, 16 4s are 64. 64 plus 32 plus 2 works out to 98. That's how you got this 98. The next one is 40 gram of NaOH. So N will be equal to 40 upon this NaOH ka Mr will be again 40. So Na is 23 oxygen is 16 and H is 1. So 23 plus 16 plus 1 works out to 40. So 40 upon 40 will be 1. So 1 mole is the answer for this. Next is 720 gram of FeO. So N will be equal to 720 upon, now FeO ka MR will be, Fe ka it is 56 and oxygen is 16. So 56 plus 16 works out to 72. So N will be equal to 720 upon 72, which works out to 10 mole. So answer for this is 10 mole. Next question, fifth one. Calculate the mass of 2 mole of zinc oxide. Now here again we have to find out the mass and the mole is given to you. So again the formula will be M will be equal to N into Mr. Okay. So N is how much? 2 multiplied by Mr of zinc oxide is how much? Mr for zinc oxide is, for zinc oxide, right? Okay. ZnO, right? So it will be 162, no, not 162, 65 for zinc and 16 for oxygen. 65 plus 16 works out to 81, and 2 times 81 is 162 gram. So the answer for this is 162 gram. Now what is the mass in gram of 0.25 mole of H2S? Okay, hydrogen sulfide. So again the formula M will be equal to N multiplied by the Mr. So N is 0.25 multiplied by Mr. Mr for H2S will be, for H it will be 2 and for S it will be 32. So 32 plus 2 is 34. So 0.25 multiplied by 34, which works out to 8.5 grams. C is 0.35 mole of copper sulfate. So M will be equal to 0.35, that is N, multiplied by the Mr of CuSO4. Now Mr of CuSO4 will be this. For Cu you will take 63.5, for sulfur you will take 32, and for 4 oxygen you will take 16 into 4, that is 64. When you add up all these three, you will get 159.5. That multiplied by 0.35 will give you 55.825 grams. So this is the answer for C. Next question, sixth one. Calculate the number of moles at RTP. Okay. Now the number of moles at RTP. Now this is 2 decimeter cube of carbon dioxide. Now here in this question you will see that all these three molecules are nothing but gases. CO2, carbon dioxide, is a gas. SO2, sulfur dioxide, is a gas. CO, carbon monoxide, is also a gas. And you know that any gas, any gas, if you take 1 mole of that gas, then it will contain the volume as 24 decimeter cube or 24 liters. Okay, and you have to calculate the mole of this. Okay, so the relationship is number of moles N is equal to V in liters divided by 24. Okay, this is the relationship that you have to use. So for the first one, V is given as 2 decimeter cube, so V will take as 2 and divided by 24. Okay, so 2 divided by 24 is 1 by 12. That works out to 0.083 mole. So the first one ka A ka answer is 0.083 mole. B is 240 decimeter cube of SO2. Again it is a gas. So N will be equal to volume in liter, that is 240 decimeter cube, divided by 24. That works out to 10 moles. Then for the third one, N will be equal to the volume in liters, okay, or in decimeter cube. Now this is 20 centimeter cube. So 20 centimeter cube, if you want to convert it into decimeter cube, then what you have to do is you have to divide that by 1000. So 20 centimeter cube is equal to 20 upon 1000 decimeter cube. So I'll take 20 upon 1000 divided by 24. If I rearrange it, I get the answer as 20 upon 1000 into 1 upon 24, which works out to 8.33 into 10 raised to minus 4 mole. So this is the answer for the C part of this question. Next question is question number 7. Calculate the volume of 0.3 mole of hydrochloric acid or HCl. Okay. So you have to calculate the volume and the number of moles is given to you. So again you'll have to take this N equal to V upon 24. Okay. Now this is not hydrochloric acid. This must be hydrogen chloride gas. Okay. So N will be equal to V upon 24. N is given as 0.3 and 24 you have to multiply. You will get the volume. So 0.3 into 24 works out to 7.2 and 7.2 liter is the volume needed. B is 4.4 grams of carbon dioxide. Okay, now this is 4.4 gram. Okay, So here you are going to use this formula, N is equal to M upon Mr. Okay, M will be 4.4 and Mr for carbon dioxide is 44. So N will be equal to 4.4 upon 44, which works out to 0.1 mole. Okay, so I'll write here 0.1 mole. Right now, okay. Uh, you have to calculate the volume. Okay, so we have just done the mole. Now using this formula, volume is equal to N times 24. N is the number of moles, so we got the mole as 0.1. That multiplied by 24 will be 2.4 liter. So this is the answer, 2.4 liter. Okay, so don't stop at 0.1 mole. They will ask you to find out the volume. C part of the question is 34 gram of ammonia gas. Okay, so first we'll find out from this 34 gram, we will find out the number of moles. So N is equal to M upon Mr. M will take as 34 and Mr for ammonia will be 17. 34 upon 17 works out to 2 mole. Okay, so 2 mole is the value of this thing, mole, okay, of ammonia. But we have to find out volume. So volume will be equal to 2 times 24. Okay, so 2 times 24 means 48 liters. So this is the answer. Next question is, calculate the concentration of a solution containing A and B. Now A says that 0.2 mole of NaOH dissolved in water and made to 100 centimeter cube. Okay, so 0.2 mole NaOH you have to take N as 0.2 and volume you have to take 100 centimeter cube and you have to find out concentration. Now concentration के लिए formula you will have to use this one. N is equal to C into V. Okay, N is the number of moles which is given as 0.2 and C is something you have to find out and V is the volume that is given as 100 centimeter cube. But you have to take care of the units. Okay, so we'll arrange this as C is equal to N upon V, and N we will take 0.2 and volume we are not going to take 100, we are going to take 100 upon 1000 because centimeter cube we have to convert it into decimeter cube. So 100 upon 1000 you will have to do. This is decimeter cube. This is mole. Okay. Now if you do this calculation 0.2 into 1000 upon 100, that works out to 2 and the unit will be mole per decimeter cube, or you can say mole per liter. You can write this as mole per decimeter cube as well. That was A part of the answer. This is B part. 9.8 gram of sulfuric acid dissolved in water to make 500 centimeter cube. So from 9.8 gram, we are going to calculate first the number of moles. So N will be equal to 9.8 upon Mr. 9.8 upon Mr for sulfuric acid is 98 and 9.8 upon 98 works out to 0.1 mole. So you got N for sulfuric acid. Then C will be equal to, concentration will be equal to number of moles divided by volume. Number of moles just now we got 0.1 and volume is 500 centimeter cube, but we have to convert it into decimeter cube. So 500 upon 1000, that works out to 1 upon 10 into 10 upon 5, which works out to 0.2 and the unit will be for concentration mole per liter or mole per decimeter cube. Okay. Next question, question number 9. Calculate the mass of copper 2 sulfate CuSO4 which needs to be used to prepare 500 centimeter cube of 0.1 mole per decimeter cube. So concentration is given to you, volume is given to you, and you are asked to do what? Calculate the mass. Okay, so you have to calculate the mass of CuSO4. Fine. So A part of the question first we'll do. So N will be equal to V into C, right? So N is something that is not given, right? So we'll first find out N. N will be equal to V, volume. Volume is given as 500 centimeter cube. So 500 upon 1000 multiplied by C, concentration is given as 0.1. So this, if you work out 500 upon 1000 into 0.1, this will work out to 1 by 2 into 1 by 10. That is 1 by 20. So 0.05 mole. This is the N value for CuSO4. Now from this N value, we want to find out mass. So N will be equal to mass upon Mr. So N is 0.05 into Mr will be equal to mass. Now Mr for this copper sulfate is 159.5. Okay. if you do the summation of all these AR values of copper, sulfate, sulfur and oxygen, you will get this 159.5. So mass will be equal to 0.05 into 159.5, which works out to 7.925 grams. So this is the mass of copper sulfate. That was A part of the question. B is you have to find the mass of KNO3, potassium nitrate, which is to be used to prepare 200 centimeter cube of 2 mole per decimeter cube solution. So concentration is given to you, volume is given to you, and you have to find out the mass. So first, as usual, we'll find out the N value. N will be equal to volume into concentration. Volume will be 200 upon 1000 because it is 200 centimeter cube. So 200 upon 1000, and concentration is given as 2. So you'll have to take this 200 upon 1000 into 2. That works out to 1 by 5 into 2. That works out to 0.2 into 2. That works out to 0.4 mole. So this is the N value for this KOH. Okay. Is it KOH? KNO3. Okay. Next, N you got 0.4. From this, you will have to find out now mass. So N is equal to mass upon MR. So 0.4, N value is 0.4. M you keep as it is upon MR. MR for KNO3 will be, for K it is 39, for nitrogen it is 14, and for O it is 16, but there are 3 O. So 16 3s are 48. When you add up all these 3, you get 101. So MR will be 101. 101 into 0.4 will give you the mass. That works out to 40.4 gram. So this is the answer. Next is 10th one. How many atoms are there in 0.25 mole of aluminium? Now here again he has asked you how many atoms are there. Okay. How many atoms? So he's asking you number of particles. Right. That is in 0.25 moles of aluminium. So 1 mole of aluminium will contain 6.02 into 10 raised to 23 atoms. Therefore, 0.25 mole will contain how much? So it will be 0.25 into 6.02 into 10 raised to 23 times 1. So the answer will be 6.02 into 10 raised to 23 into 0.25, which works out to 1.51 into 10 raised to 23. Now here you won't have any units because this is the number of atoms. Okay, so you'll write atoms, right? Same way, B part is in 0.15 mole of magnesium, how many atoms will be there? So in 1 mole of magnesium, you have 6.02 into 10 raised to 23 atom. This is the definition of mole. In 1 mole of any substance, you have 6.02 into 10 raised to 23 particles. Now, since this is magnesium element, so you'll have atoms. Okay, so magnesium atoms, 6.02 into 10 raised to 23 atoms. So 0.15 mole will contain how much? So it will be 0.15 into 6.02 into 10 raised to 23. This will be the answer. If you work out this, you should get 0.903 into 10 raised to 23. Sorry, this will work out to 0.903 into 10 raised to minus 3. Okay, and this will again work out to 9.03 into 10 raised to minus 4. Okay, now I'm not very sure about this. Let me check it. 6.02 into 10 raised to 23 into 0.15, right? Let me check it. 6.02 into 0.15. Okay, this works out to 0.903, right? Into, this is 10 raised to 23. Okay, it's not 10 raised to minus 3, it's 10 raised to 23. 1 second. Huh? Yeah. Oh, wow. Yeah. This will be 10 raised to, this should go. Okay. 10 raised to 23. Fine. So 0.903 into 10 raised to 23, and this can be written as 9.03 multiplied by 10, so divide by 10, so this will be 22. Okay, so this is the answer, 9.03 into 10 raised to 22 atoms, right? Next question, 11th. How many moles of calcium contain 1.204 into 10 raised to 24 atoms? Now this is the reverse one. Okay. Now 1 mole of calcium will contain 6.02 into 10 raised to 23 atoms. Therefore, how many moles will contain this many atoms? 1.204 into 10 raised to 24. So unitary method, if you use, this will be this into this, that is 1.204 into 10 raised to 24 divided by this quantity, that is 6.02 into 10 raised to 23. And when you work out this, you will get 0.2 into 10, which works out to 2. So answer will be 2 moles. Okay, so corresponding to this many atoms of calcium, you will say that it is 2 moles of calcium. So answer is 2 moles. Now, in the next session, in the next video, I'm going to start with this mole and the chemical equations. Okay. Now, this will be a level higher than what we did just now. Now, these questions that we did right now, okay, these were just making use of those 3 4 formulas, where from the grams you have to convert it into moles, from moles into gram, from moles to volume, from volume to moles, from moles to concentration, etc., all that. Okay, so those simple formulas, 3 4 formulas we used and we worked on that. Now we are going to, in the next session, we are going to start with moles and chemical equations. Now this is the real stoichiometry that you have to study, but this will be starting next time in the next video. That's all for today. And if you happen to like my video, please subscribe my channel, and that will motivate me to make more and more such videos. So that's all for today. Good night and see you all.